Hello students, good morning to everyone. In our last video, we discussed about isosceles triangles. We did two theorems and did some problems relating to isosceles triangle. Today, we will discuss a new topic, that is indices of algebra portion. You already learnt indices in your earlier classes, but here we recall our rules of the indices, what you learnt in your earlier classes, and then we will go ahead and do more examples, more problems. First, let us come and discuss the rules of the indices or rules of the exponents. Now, the indices or exponent, a plus a plus a is equal to a plus a plus a, that is equal to 3a. 1a plus 1a plus 1a means 1 mango plus 1 mango plus 1 mango, that is 3 mango. So that is 3a. But a into a is not equal to 3a. Most of students make wrong in this case. They do not judge a into a, what will be the value, a plus a, what will be the value. So a plus a is equal to 3a, but a into a, that is equal to a to the power 3 or a cube. A into a, that is equal to a cube. Suppose I write another thing, 2a cube. 2a cube means this is the exponents. A cube is exponent, a to the power 3. So a to the power 3, here what is 2 other than the exponent, that is coefficient. You will learn the coefficient briefly in your next class, 10th class, while you will study in quadratic equation, coefficient of x square, coefficient of x and constant term. Now just know this is coefficient, 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 but it is not our matter. Our topic is a cube, exponent. So exponent, a cube is a exponent. Here a cube is also a factor, 2 is a factor, a cube is a factor, 2 is a factor, or otherwise it is called the coefficient of a cube. And a cube, in a cube, what is a? A is a base. And what is 3? 3 is power. Or exponent or index. 3 is the power, exponent, index, and a is the base. What we will read this? A power 3 or a raised to the power 3, or simply we will read a to the power 3 or a cube. When power 3, it will be read in another way a cube, power is 2, a to the power 2, otherwise we will read it a square. Now this is the basic things we already learned in your earlier classes. Now we recall the formula or rules relating to indices. What is the rules of relating to indices? Now first law, that is product law. Product law. A to the power m into a to the power n, that is equal to a to the power m plus n. First law is a product law. When two indices multiplied to each other and their bases are same but index are different, the base of the product will be the same and the index will be added. So here is the same base a and a base same, power or index different. So a to the base same base same base same base. So if it is multiplied, so power added. If it is divided, power subtracted. So it is the product law. Just an example, x to the power 5 into x to the power 3, that is equal to x to the power 5 into x to the power 3 is equal to x to the power 5 plus 3, that is equal to x to the power 8. One example. We will do many more examples, many more questions after discussing the rules of indices. Next, second law. Second law, quotient law, Quotient, quotient law. That is equal to a to the power m upon a to the power n is equal to a to the power m upon a to the power n, that is equal to a to the power m minus n. A to the power m upon a to the power n is equal to a to the power m minus n. A to the power m minus n. This is the second law. Just example, x to the power 5 upon x to the power 3 is equal to x to the power 5 minus 3, that is equal to x to the power 2 or x square. This is the quotient law. Product law, power added. Quotient law, power subtracted. Numerator power minus denominator power. Then come to third law. That is a power law. Third law is a power law. What is third law? A to the power m whole to the power n. A to the power m whole to the power n, that is equal to a to the power m into n, that is mn. So power to power, the product of a power. Just an example, x to the power 2 whole to the power 3, that is equal to x to the power 2 into 3, that is equal to x to the power 6. x to the power 2 whole to the power 3 is equal to x to the power 2 into 3 power into power, that is equal to x to the power 6. This is the first law, product law, second law, quotient law, and third law is power law. In first law, index are added. Second law, index subtracted to each other. Power law, index will be multiplied. A to the power m into a to the power n, that is equal to a to the power m plus n. That is product law. Second law, a to the power m upon a to the power n, that is equal to a to the power m minus n. Quotient law. And third law, a to the power m whole to the power n, that is equal to a to the power m into n, that is equal to a to the power mn. The three law is main important law relating to indices. Then we will discuss another law which is not important but essential. Take a screenshot. Positive, negative, fraction, zero index, zero, number 1. Positive, base index. If base is positive, index is negative, base is negative, index is positive, base is negative, index is negative, what will be the answer? Now we will discuss. Now first, a into b to the whole to the power n, a into b to the power n, that is equal to what? A into b to the power n, that is equal to a to the power n into b to the power n. If a into b to the power n, then a to the power n into b to the power n. In this case, bracket is very important. If here is written a into b to the power n, we cannot write. It is not equal to a to the power n into b to the power n, because here is no bracket. So n is the power. At that time base is b, only b. But here n is the power or index. The base is a into b. So a to the power n into b to the power 1. But in this case, a into b to the power n. That means a alone is a factor. B to the power n is a factor. So a to the power n, b to the power n is wrong. It is a wrong procedure. Is not equal to b a to the power n into b to the power n. This is the formula. This is not write this. Then number 2. A to the power m upon b to the power m. Look, when two indices divided to each other, their index is same but base different. So base upon base whole to the power 1 index, that is equal to a upon b whole power m. This is the second. Or a into b to the power n, a to the power n into b to the power n, a to the power m upon b to the power m, that is equal to a upon b to the power m. Second, then third technique, if a is not equal to 0, n is an element of z, means integer. Z is a set. You have no set in your classes, but in CBSE there is a set. But in set, natural number set, integers, rational number, irrational number, real number, imaginary number, there is a set. Imaginary number, rational number set R set, real number set R set, rational number set Q set, irrational number set Q dash set, and integers I or Z. So A is not equal to 0, n belongs to Z. So nth root of A is equal to a to the power 1 upon a. If a is not equal to 0, 0 to the power something is impossible. So a is not equal to 0. n is belongs to a natural number. n may be 0, may not be 0. It may be negative number, positive number, or 0, whatever it may be, but a cannot be 0. In that case, nth root of a is equal to a to the power n, or x to the power 1 upon 2 is equal to x to the power 1 upon 2 is equal to square root of x. We know that when we omit square on the left side of a equation, then we put square root. What is the meaning of square root? The meaning of square root is x to the power 1 upon 2. This is the indices. So all things turn into the index and base. Then next, take a screenshot. A to the power m upon n, that is equal to a to the power m upon n is equal to, we can write a to the power a to the power 1 upon n to the power m, that is equal to nth root of a to the power m. Nth root of a to the power n, just same thing. 1 upon n, n comes to nth root and a to the power m. This is the next rule. Number 4, if a is a non-zero number, a is a non-zero number, a is a non-zero number, a to the power n. A is a non-zero number, means a is not a 0. So a to the power n, n may be 0, may not be 0, but a cannot be 0. A to the power n is equal to 1 upon a to the power minus n. If a is a non-zero number, then a to the power n is equal to 1 upon a to the power 1 upon a to the power minus n. Then a to the power minus n is equal to 1 upon a to the power n. A to the power minus n is equal to 1 upon a to the power n. Then next, number 5, any non-zero number, any non-zero number raised to the power zero is always 1. Any non-zero number instead of 0, any number raised to the power 0 is equal to 1. Very important. Means 2 to the power 0 is equal to 1. X to the power 0 is equal to 1. But 0 to the power 0 is not equal to 1. But anything else, x to the power 0 is equal to 1. Any non-zero number raised to the power 0 is always 1. Then minus a to the power m is equal to a to the power m. Minus a to the power m is equal to a to the power m when m is equal to even number. When m is even number, the minus power of a minus power m or even number, that is plus, and minus automatically omitted. So minus to the power any even number, that is plus. Minus to the power any odd number, that is minus. So minus a to the power m, that is equal to minus a to the power m. Here m is odd number. A is odd number. So we know. Now take a screenshot. Minus a to the power m is equal to a to the power m when m is even number. Minus a to the power m is equal to minus a to the power m when m is odd number. And this much is the formula, the basic formula or fundamental law of indices is product law, quotient law and power law. Product law, what is the product law? A to the power m into a to the power n, that is equal base equal index different sum of the index. So a to the power m plus n. Then quotient law, a to the power m upon a to the power n, the base equal in numerator and denominator, but power or index are different, that is a to the power m minus n. Then power law, a to the power m whole to the power n, that is equal to a to the power m n. Then we discussed a to the power m into a to the power m into a to the power b to the power m. A to the power m into b to the power m is equal to a into b to the power m when index are same, bases are different, but they are multiplied. The product of their product is equal to base into base to the power index. Then likewise a to the power m upon b to the power m when base are different, index are same, but they are divided to each other, then base upon base a upon b to the power m, and any non-zero number to the power 0 is equal to 1, and minus a to the power m, that is equal to a to the power m when m is even number, minus a to the power m, that is equal to minus a to the power m when m is odd number. This is the laws and some techniques relating to index or exponents. Then in our next class we will briefly discuss about the examples and problems relating to exponents. For today, now you are practice this laws, then we will start the problems for this for today this much. Thanks, goodbye.